Alright, we're going to show you basically your two options with the LFP40 version 3. And what we're offering are two simple packages. One is for get you the most basically solar panel for your money. They are the mass-produced 120 watt folding glass panel sets. The system can handle 220 watt folding panel sets at one time. So two panels will produce 200 watts and provide the quickest recharge time that the system is capable of providing, which is about 2.5 hours from completely dead to 100% fully recharged. And these panels are 27 pounds each. They're made out of glass. They're tempered glass, so they're designed to withstand hail. They're the same type of panels that you see on buildings and houses all over the world, so they're pretty rugged. They will break if you hit them hard enough, but if you take care of them, shouldn't be an issue. For most people who don't need to hike panels through the woods for miles and miles, or people who are just going to be using the system at their house, this is a very good, affordable way to generate solar power. So we recommend it. The other option we have, if weight is an issue and the budget allows it, we are pairing the system up with up to 4 62 watt folding non-glass solar panels. And each one of these panels is 62 watts, weighs 3 pounds, which is the lightest panel on the market. It's used by U.S. military all over the world. And we'll show these laid out in a minute, but the system can handle up to 4 of these. So the system can handle 200 watts continuously on the solar input side. So 4 62 watt panels would max the system out, or 2 120 watt glass folding panels will max the system out for the lowest cost. And then the highest cost are obviously the folding panels at 3 pounds each. The LFP40 weighs 19.6 pounds. Each glass panel weighs approximately 27 pounds each. Each 62 watt non-glass folding panel weighs 3 pounds each. So that's that. We'll lay them out and show you what it looks like. Both combos laid out and set up. And here are what the two 62 watt non-glass folding panels look like laid out. We can go with up to 4 panels for this system. There are rivets in all 4 corners of these panels, so you can stake them down to the ground to keep them secure, or you can pull them with bungee cords or rope to get them to tilt at any angle that you would need them to tilt to get maximum output. But pretty good setup, used by U.S. military all over the place. The panels are mil-spec rated, so they passed military testing. Now we'll show you the glass panels. So here are the 220 watt glass folding solar panel sets, and you can see that they're angled towards the setting sun. It's about 6 o'clock. We're in California, sun setting, and tilting the panels during the evening and morning hours can double the output versus a panel laying flat. So another thing we really like about the 120 watt folding panels are the built-in tilting arms. So on each top and right corners, there's an arm that'll pop out and allow you to angle the panels toward the sunlight, and that maximizes the amount of power you harvest, or the amount of power that the panels are actually putting out. And then we take that power, use it, or store it in the LFP40 V3. The panels have regular Anderson 75 amp Anderson power pole connectors on them, and the cable that comes with the system, which is in the Maxpedition bag that we have here. Here's our connector for our solar input that connects to the LFP40 system, and then here's one, and we have another 75 amp Anderson power pole connector that mates right up with this, locks in place. And once we connect that to our system, we will be generating up to 200 watts of continuous solar input. That can be used to charge the LFP40 in about 2.5 hours, or we can use it to directly power devices from sunlight via DC or AC power. So those are our two solar panel options. This is the most affordable option. You can use one or two panels, or you can go with the 62 watt folding non-glass panels, 3 pounds each. Alright, so we've connected both solar panels to the solar panel cable. We've locked the first panel into place. You can't do it backwards. We locked the second panel into place. We have 55 feet of cord to go from the panels to the actual LFP40 system. Now, here is the connector that comes from the panels to the system, and there is a port right here on the side that has a spring-loaded cover. We lift the spring-loaded cover up, and we're going to push this in, and we're going to start collecting solar power. Alright, so the major upgrade we have for the LFP40 V3 is battery monitor. So this is a digital battery monitor that shows you all the critical battery data, so you know exactly how much power that you have left in the system. You actually know how many hours and minutes you have until the system will need to be recharged based on what you have plugged into it, so it calculates that for you. We have a simple one button on, off, and reset switch. So when you see green right here, you see green in the center of the button. This is a latching button, so when you push it down it stays, when you push it up it stays. When you see green, that means we have 12 volt power being supplied to our input-output ports. And when we push the button down, the green LED is not lit, showing that there's no power being output from the system. Push the button up, green LED turns on, showing that the system is good. If you ever need to reset any of the breakers, or if the battery ever protected itself from over current or over voltage, you can always reset it by pushing it down, pushing it up. If you have it in the up position and there's no green LED, check the battery monitor for the amount of power that's in it. If it's not drained, you just need to cycle it to reset it. If the button is in the up position and the green LED is off, more than likely the system is discharged and needs to be recharged, and as soon as you recharge it, the light will turn back on. So the battery monitor gives us a lot of critical data. So SOC is state of charge. We have a 96.6% capacity left in the system right now. So we're 96.6% fully charged. And as you discharge it, that number will go down. And as you charge it, the number will go up to 100 when you're 100% charged. Consumed energy is the CE, that's 1.4 amp hours. This is a 40 amp hour system, so we've consumed 1.4 amp hours, which is 96.6% is what it leaves in the system. If you go to I, this is current, so this is actually like the amount of power that's being pushed in. So if the number is positive, no negative sign, that means we're putting power into the system. So if we take our solar panel input cord right here and we connect it to the solar input port, what we should see is a positive number. So right now, the sun's about to set, but since the glass panels are tilted, we're still producing about 6 amps of power. It's a decent amount of power. So since there's no negative sign, that means we're pushing that much power into the battery right now. When it becomes fully charged, it'll stop and it will not overcharge the battery. But right now you can see exactly how much power the panels are producing, which is 5.87 amps. Battery voltage, that's what the V stands for. We're at 13.41 volts. When the battery is fully charged, it's going to go to 14.4, 14.6. when you pull the charging off, when charging stops, it'll drop back down to this when it's fully charged, and when it's empty, it's going to be at 10.5 volts. Time to go is infinity. That's because we are putting power into the system, so the system can go forever as long as it is in a positive state of charge. If we were draining the system, we would see in hours and minutes until it would be dead based on what we were currently powering. And then we're back to state of charge, 96.9, and that's going to go up because we're charging it. So that's all we need to do to charge it. We either hook up our glass panels or our 3-pound 62-watt folding panels with the supplied cable. Plug it into this port, and you can see our state of charge is going up 97%. We're producing 6.14 amps. The system has multiple power point tracking built in, so it will continuously scan the solar panels for the voltage that supplies the most current. It'll lock the panels at that voltage every 3 to 5 minutes, and then it'll continue to do that to basically maximize the amount of power that you're harvesting from the panels. This is our Deltran connector. It is good for 60 amps. This is the port we use to connect our 800-watt inverter. This is the port we use to expand our system with extra battery modules, and this is the port that we'll connect our high power accessories to. There's a nice cover. When you're not using it, it pops right in place. This is our 200-watt solar input port. It can handle solar panels with the open circuit voltage of up to 75 volts, and the max current it can handle at one time is 200 watts, 15 amps. The 2 cigarette lighter output ports are right here. Same cigarette lighter output ports you have in your vehicle. Nice covers that cover them. They're good for 200 watts each. So each port you can pull 200 watts out of. They're protected by an automatic reset breaker. So if you pull more than 200, the breaker will cut the output off, and then you can reset it by cycling the on and off button. So turn it off, turn it back on, and the breaker will reset. If you lose power at any one of these ports, or you're pulling a lot of power out of them, and it stops, then cycle it on and off. You should turn your output back on if that's what you've done. So here's the bag that comes with the system. It's a military grade Maxpedition bag, and inside our front main compartment is what holds our solar panel, 55-foot solar panel cable. Inside a back pocket here is a 10 amp AC battery charger. It has 110 volt and 220 volt AC input. You can select by a switch. It's got a regular US style house plug on it, and then the other end has a cigarette lighter cord. You simply plug it in to your AC outlet at home or while you're traveling, and then you plug the cigarette lighter input into the cigarette lighter port. That will start charging and then fully charge the battery from dead to full in about 4 to 5 hours. There are rapid chargers available if you need them, but they are more expensive. So if you need 2-hour, 1-hour charging, then contact us and we'll work that up for you. Top of the bag is a 3-watt. This particular system has a 3-watt LED light. So this is a 12-volt light with a magnetic flexible base tripod, which you connect or attach to metal devices, or you can basically wrap this around anything. And it's a good light, low power consumption, and provides a decent amount of light for the power that it consumes. It is waterproof, so you can leave it outside, you can submerge it in water, it won't electrocute anything, you don't have to worry about it ruining the light. That's the main advantage over the cheap CFL lights that you can buy, is that it's safe to use in wet environments, and it consumes less energy than CFL lights also. So that goes in the top bag. We also have 6-watt versions, which produce double the amount of light. Still has the low power output rating. Next, we're going to show you the 800-watt 12-volt inverter. So here is our 800-watt peak, 640-watt continuous 12 volt to 120 volt AC output inverter. It's got a digital display on it. It's got our heavy duty high current locking connector, which goes into our input output connector in the back right here. This is an upgrade from the last LFP40 that we built, and we've upgraded to the next size up inverter. One of the advantages is it has a thermally activated fan, so the fan in the back will only run when the internal temperature reaches about 120 degrees. It cut down on the amount of time that the fan ran compared to the last one. The last one would run anytime you were pulling over 100 watts. So this one's a lot quieter. It can handle higher loads. So the LFP40 V3 has been upgraded in power output rating also. So instead of 40 amps, we can now pull up to 60 amps peak. About 50 to 55 would be continuous. This inverter can supply about 600 watts before the output will shut off from overcurrent. So we supplied you with a heavier duty inverter so you can power larger loads and you're not overstressing the smaller type inverter. So we like it a lot better. It just seems to be a better inverter. It's quieter. It has the digital display. So you hold it down, it turns on, shows you the LEDs are working. Shows the output voltage, this is 13.7. And when we plug in devices, it'll show watts. So right now it's showing 0, but when we power devices, it'll show an estimated, or fairly accurate estimated wattage that the AC side is supplying to the system, to the connected device. And then the system will actually show you how many amps that the battery is supplying to make that amount of wattage. You hit it again and it shows the output voltage, so it's 115 volts coming out. Battery's at 13.7 and wattage is 0 because we have nothing plugged in. Alright, so we got our inverter hooked up. We're charging a camera battery, which is one of the batteries is powering the camera we're using right now. Plugged it in just like a regular wall outlet. We're consuming so little power, it's going to show that we're basically not pulling any power right now. We unplugged our solar input, which means we have no power coming in. And what we're going to look at is current, which is I. We've got a negative sign now. That means we're pulling power out of the system. We're pulling 1 amp to charge this battery and to run the inverter at the same time. So that shows you exactly how much power you have coming out. Battery voltage, time to go. So it takes 60 seconds for the time to go to read an accurate number, and what it's doing is taking the power consumption over a 1 minute time frame, calculating that based upon how much power is in the battery, which is 99.2%, and then after 1 minute it'll tell us exactly how many hours and minutes we have until the battery will be drained based on what we're powering at that given time. So we have a 40 amp hour battery. We're consuming about 1 amp of power fluctuating. It's going to calculate based on the average of that fluctuation right there. We've consumed 0.3 amp hours out of 40, 99.2% charged. Time to go. If we're consuming 1 amp of power and we have 40 amp hours, the number should be right around 40 hours, which is right where it is. So it's going to settle out at whatever that number is, the average of our current consumption over a 1 minute time frame. So you can see it's slowing down. And this is one of the coolest features of this system, is you know exactly how much power you have and how much power you have until your battery is going to be drained. And when the system is fully drained, it automatically cut the output off. So you cannot over drain the system, which is the most damaging thing you can do to a battery as far as its lifespan, is to over drain it. This system is rated to provide 2,000 charge and discharge cycles if you charge it from 100% full and drain it to 0. This is the worst thing you can do to the battery. These batteries are superior to any other battery on the market when it comes to life cycles and deep discharge. So you can see we've settled into about 39 to 40 hours based on what we're powering here, which is just charging a small Sony camcorder battery. Now we can take out our LED light right here. Set this up real quick. So we have our LED light pulled out. We're still charging our camcorder battery. Here's the cigarette lighter plug for the LED light. And we'll just show you how the time to go is affected by plugging in more devices and how it automatically calculates that. So you can see the time's going back up, and that's because basically the amount of power that we're pulling out is dropping because the battery's charging. But let's go ahead and plug in our LED light, which actually consumes very little power, so it shouldn't make much of a difference. We'll plug that in. Got the red light showing that we have power to that port. And we see our current consumption has went up a little bit, but not much. The light is on. The 6-watt light would pull double the amount here, but our time to go will automatically drop. It takes 60 seconds to get an accurate number on this, but you can see we're going to get less runtime, or we're going to discharge the battery faster the more we plug in. So we've lost 4 hours by running the battery, or the LED light, plus the battery charger. So what's cool is it automatically calculates this for you. Before adding this to this particular system, which is one of our most popular systems, it was just a guess. You really had no idea how much power you had, so you just kind of had to gauge it, and you know, when you ran out, you ran out. With this, you have highly accurate information to help you basically accomplish whatever your goal is, whether it's lighting all night, a fan to cool all night, to run multiple laptops, whatever it is you're trying to do, this is probably going to be helpful to you. So that's that. When the system hits 10.5 volts, this monitor will show an alarm. It'll start beeping to let you know that you've hit that. Once you hit 10.5 volts, 60 seconds later the output automatically shuts off, which will keep you from over draining the battery. So all these ports will no longer supply current, and to recharge the system you will need to either plug in the solar panels, and this will do this automatically the next day. So the next day, if you, let's plug that back in and see if we can get a stable number. The next day, if you drain it overnight and you have the panels plugged into it at nighttime, when the sun comes back up, it'll automatically reset the system. It'll start charging and recharge your battery when the sunlight comes out. If you don't have solar and you're just inside, you use the 10 amp battery charger that's in the back of this case here. You plug the other end, the cigarette lighter in, into the cigarette lighter port, and you'll watch the battery state of charge start to increase. You could recharge it that way also. That will turn your outputs back on. If you're going to store the system, simply push the output off, which we can do right now. You can see the inverter has shut off, the light has shut off. Our time to go is infinity because we're not consuming any power. And if we turn the system back on, LED light's back on, and this one has to be manually turned back on. So this is a much more simple setup for people to use. It's a refined system after building many of the old LFP40s. It's superior, it's lighter, it's 19.5 pounds.